Hi, these capsule lessons are aimed at reinforcing the concepts as well as to emphasize on the key points that you need to remember for examinations. If you already revised the concepts and are looking for ways to improve your application skills, then continue watching. The sessions are split into, there is a small recap of the concepts or the points that you need to remember, and then you will have a couple of questions, examination questions to solve. You can pause the video, try to solve it on your own, or just go through the question, understand what it demands or how to crack the question, etc. Then follow me solving the questions. I hope that at the end of the session you will get a better understanding of the concept and a good grip of the same. All the best to you all. See you in the video. This session we are going to see about electrical circuit problems. Now, I'll not be going into the theory as I said earlier. We'll just go through the point that you need to remember when you get questions based on electric circuits in IGCSE. All right. Now, many a times, students get confused. They think, oh, this I don't get it right. It's very difficult, etc. But then I will tell you, it's not difficult. If you know how to step by step proceed. If you know the procedure, then it's very easy for you. All right. You need to know certain points. Just remember those points while you're solving, and I'm pretty sure you will get it right every time. All right. Now we'll see what you have to remember. Before that, an example I'll give you. Now, see, you have two formulae, mainly two formulae you'll be using in these type of circuits, right? Yeah. So, Ohm's law, you have V is equal to IR, and power, voltage times current. So there is no, or it's not a very complicated formula that you'll be applying here. So where does the confusion arise, or where do you go wrong? It is the substitution, right? Now here, if you look at one circuit, I've got three components. Okay, imagine like in a bank, you've got some deposit. Say the battery is like your amount that you have deposited, and like these two are like the amount that you have withdrawn. If you're asked to calculate the interest for one of your withdrawals, like in an ATM machine, you've done a couple of withdrawals, and if you want to calculate how much was the interest, or how much have I lost in interest, etc., whatever calculation, right? Now, the formula might be the same for calculating the interest for the amount here, the amount that you have taken here and here, right? Formula is the same. But if you want to calculate for one particular transaction, if you're substituting the amount that is already there in the bank, would that give you a right answer? No, correct? So this is also very similar to that. The formula is the same, V is equal to IR, but what you're going to substitute in each of the calculation, that's important. Okay. Now, what do I mean by that? Say, we know the voltage of the battery will be divided between the two resistors here. Why? Because it's a series circuit. So the V will not be the same for each of these resistors. So you have to keep that in mind, because basic tendency is, if you know that I and V value is given here, say this is 12 volts and this I is like 2 amperes. If you're asked to find out the resistance of the first component, your tendency would be V, I know it, okay, I know it, let me substitute, correct? But that's wrong. Why? Because you're taking the V of the battery and you're using it for this component. This whole voltage, this 12 volt, will not be used up by this resistor alone. It's shared between the two. So if they have equal resistances, it will be divided between equally. You will get 6 volt and 6 volt. So I'm trying to make you understand, or trying to take away the misconception. V is equal to IR formula, you cannot just blindly use it. You need to think for which component you are using, whether it's for the battery you're trying to calculate the current flowing through it, or if you're trying to find out through a component. For that particular component, think what would be the voltage there, or is the resistance for that particular component given, or is the current going through it is known, etc. Then you can go ahead and substitute. This is point number 1. Point number 2. Now if you look at it, all right, I've got this 12 volt. If the current going through this first component is 2 amperes, if the question says, what is the current flowing through the battery? All right. Now, will you be sitting and doing calculation? Is it necessary? No, you use the concept in a series circuit. The current will be the same at every single point. Now in IGCSE, if you're not expected to give a calculation, if there is no calculation involved, you can look at the mark that is allotted for that question. If it is 1 mark, then you just have to pick some value and write. So the value is already there somewhere in the question, right? If it has 3 marks, definitely there is a formula to be substituted and you're doing some calculations to get the right answer. All right. So here, if you have the current flowing through this component as 2 amperes, definitely is going through. All these components will have the same value. This is another point to be noted down, whether it's a series circuit or it's a parallel circuit. The voltage and current that is divided, it's not the same for these two types of circuits. As I said, here I'm just picking up important points. If you're not sure of these concepts, please go through the actual concept. There is a video that I have uploaded earlier. You can watch that carefully and then come and solve these questions. All right, here these two components are connected parallelly. So if you're trying to calculate the current going through, say, this R1, here I can take this V to be the same for these two components or any more. Why? Because it's a parallel circuit. Getting the difference? Here, if I have taken 12 for 2 amperes, it will be wrong. But here, if this was 12 and this was 2 amperes here, current flowing through, I can use 12 and 2 to find the resistance here. Why? Because the voltage between these parallel components will be the same as the battery. That's a concept application here. We get it? So don't mix up, and also remember the formula. If you have 2 resistances, if you want to calculate the total resistance in a parallel one, this is the formula. I hope you know that. And for a series, this is the formula. Third point to remember, if you're asked to find out the current that is coming or it's being drawn from the battery in a parallel circuit or in a combination circuit. What do I mean by a combination circuit? See, if I introduce another resistance here. This is a combination circuit. You've got 2 resistances in series. One resistor, this red one, it is in parallel with the other 2 resistors. So it's a combination one. So how do I find out if a question is asked, how much is the current flowing or drawn from the battery? How do I do it? Now keep the concept here is, see the current starting from here, or the current all this way up till here till it comes to the junction, current will be the same. Why? Because it's just a single strand or just the same connecting wire, the current will be the same. But here what happens, it will get split because you have got a junction. So this 2 amperes now will not be the current that is flowing through the battery. You get it? So it could be different. Say if you have calculated this to be, let's assume it's also 2 amperes. Then what will be the current drawn from here? It is going to be 4 because that gets split up here or here. Okay. Now these combination circuit or some tricky circuit, you're not sure, how to approach the question. What you need to initially do is, if the values of the resistances are given to you, try to find out the total resistance of the components in the circuit. So here we have got 3. Assume this is not a question. Say they have given you all 3 identical resistors and the values are given to you as, this is 10 ohms, this is 10 ohms, and this is also say 10 ohms. Okay. First what you would do, you would find the total resistance of all these 3 and then use it in the formula for 12 volts. Why? Because this entire resistance is affected by the total voltage. Use that, but the current that the answer that you're getting will be the current drawn from the battery. Do you get it? It is not the current flowing through any of these components. You are finding the maximum current drawn from the battery. How do you find that? Get the total resistances in the circuit, be it series, be it parallel, be it combination, whatever it is, the combined resistances of all the resistances in the circuit. Use that in the formula V is equal to IR. So this will be the total resistance. This will be the value of the power supply's potential difference or voltage. You will get the current. This current is which one? Which is flowing from the battery up till where it gets split. You get it? If it wasn't split, you will have the same current flowing through because there is only one path for the current to flow through. There is no confusion there. But if you have a combination circuit, if you have junctions, then it gets split up. Do you get it? So you've got the total voltage, the total current flowing through this, and if you're coming to a parallel circuit also, it's very similar. You get the total resistance, substitute in that voltage V is equal to IR formula using 12. You will get that current I which flows up till this junction. If you want to calculate the individual resistance, what you would do, individual current, V over R1, V over R2 will give you that current. These two should add up to the current that you have calculated earlier. I hope it's somewhat clear. Just a recap, I've given you 4 points to remember. First point, V is equal to IR formula. Check if you're using the correct, if you're substituting the correct values, all right, for one component. Second, check if it is a series or a parallel circuit. In series, you should keep it in mind the current is the same at every single point. The voltage gets divided. In a parallel, just the opposite. The voltage is parallel across the components. The current will get divided. The next point to remember is when you have, if you want to find out the current drawn from the supply, you will take the entire resistances, combine them all together. When you're combining, you should keep it in mind. You will use appropriate formula. These two are in series, so you will add it up 10 plus 10. The 20 multiplied by 10 divided by 20 plus 10 in that formula, because this combination is in parallel with this. So you have to use that formula to calculate the total resistance. That if you use it along with 12 volts, you will get the current drawn from the battery here. All right. One last point, though it's not related to problems, but since I've drawn here the direction, this actually indicates the direction of the electron that is flowing from the negative to positive direction. Okay, this is not the conventional current direction. Negative to positive is electron flow direction. Positive to negative will be your conventional current flow direction. The circuit shows 2 meters X and Y connected correctly. Which row gives the unit of the quantity measured by X and the unit of the quantity measured by Y? So here they're not asking about the meters, they're asking about the units. Now if you look at the connections, it is parallel, that is this is across the cell, and Y is connected parallel across the resistor. So both must be voltmeters. Hence, the units for these two quantities would be volt. So we have the correct answer is D, right? Because we have got both voltage. Now question 2, this involves some calculation. You can go through the question. You can pause the video if you want to now and work it out. Now, the circuit shows 3 ammeters, X, Y, and Z. Which ammeter has the largest reading? Now, if you're familiar with the concept, you have got here battery, and one ammeter is connected in the main circuit. When I say main branch, which is like the current that is flowing through this part of the circuit, and this part of the circuit will be the largest because that's carrying the current from the battery. Now we have a junction here, so X and Y will have a portion of the current through Z. So definitely Z must be having a greater current. Hence the answer is C. Now question 6. This question has got a calculation here. What could be the combined resistance of this arrangement of resistors? Now we can see the 2 resistors are connected in parallel. So you must use the formula to calculate the resistances in parallel. So 6 multiplied by 12 upon 6 plus 12, that's a simple formula, which is, so the correct answer would be A, 4 ohms. So as I said, I'm not going through the calculation, it's very simple. 6 times 12 upon 6 plus 12 will give you 4 ohms. Now question 7 is it's a straightforward one. Why are lamps in a house lighting circuit connected in parallel rather than in series? Now if you look at option 1, you can go through all the options, but the correct option is the lamps can be turned off independently using switches. If you refer to this, if you have a switch here and a switch here, we have a switch here, They are in parallel. So if you turn off this, this will still be functioning. That's a very typical example of a parallel connection where you can have independent switches. I hope you have understood this. Now moving on to the next question. Yeah. Now the diagram shows a cell connected to two 6 ohm resistors. The currents are shown, I1, I2, I3. Which row correctly compares I2 and I3 with I1? Now here if you look at it, it's a very similar question from question 1. I2 must be smaller than I1. I3 also must be smaller than I1 because these two add up to give you I1, right? So I2 is smaller than I1. I3 is also smaller than I1. I hope you got that. One more question of MCQs we can quickly go through and then move to question number 16. The circuit diagram shows, sorry about that, there's an overlap. 4 ohm resistor and 8 ohm resistor connected to a 6 volt battery. What is the current in the battery is the question. Now here, these two resistors are connected in series. So you must use the formula for resistors in series, which is R1 plus R2. We just have to add these two. You get the total resistance in some. So that's how you work it out. R total is 12 ohms. You add them up. So I is equal to V over R, which gives you 0.5. So this is your 0.5 amps is the correct answer. Question. Here it shows a 12 volt battery, but then there are 4 resistors. If you look at it, first identify whether they are parallel or series or a combination of both. Now in this question, there is a combination. You have got two A and B are in series, which is connected to C in parallel, and this entire A, B and C is connected in series with D. Alright, so this is the type of question you should be familiar with. So you have got 3 resistors. This combination is in series with D. Now question 1, but here see they've given you in sections, so it's easy for you to go through one by one. Let's see. Calculate the combined resistance of resistors A and B. Now A and B are in series, so which formula do we apply? It's addition, so you just have to add each of the resistors is just 6 ohms. So the answer here is 12 ohms. You just have to add 6 plus 6, which is 12 ohms. Now coming to the next part of the question, resistors A, B and C. So this is a parallel combination. Now if you look at it, A and B has got 12. So 12 is in parallel with the C, right? So 12 and 6 ohms are in parallel. So which formula would you apply? 12 times 6 upon 12 plus 6, you will get the total resistance. All right. So 12 times 6 upon 12 plus 6 is 18. So you get 4. So 4 ohms is the right answer. Now resistors of A, B, C and D. So now this value is for A, B and C is 4 ohms. So this 4 ohms, this entire section or these 3 resistors offer 4 ohms and this has got 6 ohms. So 4 plus 6 will give you, right, for you. This has got 6 ohms. This together is 4. This entire, all these 3 resistances offer 4 ohms, which can be considered to be as one single resistor offering a resistance of 4 ohms. So you've got 4 here and 6 here. So 4 plus 6, that will be 10 ohms will be. So the total resistance is 10 ohms. Now calculate the current in the battery. Since you've got the total resistance here, we have got the supply voltage to be 12. So the current in the battery would be, I will be equal to V over R. So it is 12 upon 10 ohms, which will give you 1.2 ohms. The next question is the energy transfer from the battery to the circuit in 50 seconds. So here energy formula is straightforward, VIT. You just have to substitute the total current in the circuit, the voltage supplied by the battery and the time. So it's VIT. So you'll get the answer to be 720 joules. So that's the correct answer.